NASA provided 3 instruments which are on the mothership, on the orbiter. We also have about 40 scientists participating jointly with the European scientists on almost all of the instruments on board of Rosetta spacecraft. We developed software that is helping the Rosetta mission plan its operations. We also have what's so-called shadow navigations. We find how far is the spacecraft from the comet at all times jointly with or side by side with the Europeans. And we also provide antennas that help us communicate with the spacecraft. On November 12th at 7:35 Pacific time, a lander will land on a comet. This is one of the hardest things that has ever been done by the human species because the comet is moving about 35,000 miles an hour, and it has unbelievably difficult terrain. There are crevices, there are craters, there's dust, there are jets coming out of it, and there are humongous boulders, boulders of the size of a single family home.
We are making a contribution to the orbiter, so we don't have any instruments on the lander. And the orbiter mission goes on for another 18 months as we're going to go around the comet all the way to the outbound leg and observe how the comet changes as it goes around the sun. If we could just get a chunk of that stuff, you know, of that original stuff that a comet is made out of, if we could just get one and analyze it, you know, how much would we learn?
The main goal of the Rosetta mission is to fully characterize a comet beyond anything we've ever done before. Comets can be seen as a window into our past, a time capsule from the origins, the beginning of our solar system. So by studying comets, we get this view of what the conditions at that time were like, where we came from, where the planets came from, and how the solar system has evolved as it is today. We'd imagined it to be this grey potato, but it's something much different to that. It's much more exciting. It's this duck or boot shape, which gives us much more to look at, much more to think about in terms of operations, but also science. Why it looks like that, how it came to look like that, is now the top of our list of things that we want to do in the near term.